Okay, so when we're looking at the BSA rule, if we know the patient's BSA and the dose is given in milligrams per meter squared, we can just take that dose times their BSA, and that will give us their dose in milligrams. So this looks very similar to the kilogram rule. So we only use this rule if the dose is given in milligrams per meter squared. So let's take a look at an example. I am on page 276. I'm in the post-test looking at number 14. So a male patient who is 5 feet 11 inches tall and weighs 185 pounds is being treated with cisplatin IV for testicular cancer. The dosage for cisplatin is 20 milligrams per meter squared per day for 5 days of each cycle. The medication is available as a powder in 10 milligram and 50 milligram vials. The medication is reconstituted to a concentration of 1 milligram per ml. Question 1. What is the patient's BSA? Well, we have their height and we have their weight, so we're going to find their BSA using the nomogram. So this is an adult. So we want to make sure that we're using the adult nomogram. And remember, the nomogram, if we're looking at the height, it's only in centimeters or inches. So the first thing I need to do is convert this height into just inches. So I know that they are 5 feet 11 inches tall. Well, 5 feet, if I convert that into inches, 5 times 12, because there's 12 inches in a foot, would give me 60 inches, and I still want to add in that 11 inches. So they are 71 inches tall, and they weigh 185 pounds. So if I'm using my nomogram, I want to make a mark at 71 inches here, and they are 185 pounds, so I'm looking at the pounds column all the way down here. Now this is 82,468, so these are going by 2, so 185, 2, 4, 6, it's going to be right in between 4 and 6. So now I get my straight edge here, and we're going to go from, just make sure I got the right mark. They're 71 inches and they're 185 pounds. So 71 here and 185 here. Line those up, and then I'm going to make a mark here on my chart. So it looks like they're right at 2.1 meters squared. So their BSA 2.1 meters squared. Now, what strength of medication should be administered per dose? Well, remember, if I look at my rule here, I have their dose in milligrams per meter squared, and now I have their BSA. So I'm just going to multiply those two together. So the BSA, we had 2.1 meters squared times the dose, which was 20 milligram per meter squared. So I can see that my meters squared are just going to cancel out. So 20 times 2.1 gives me 42 milligrams per dose. Now it says which vial should be reconstituted to provide the ordered dose. So now I have a 10 milligram vial and a 50 milligram vial. Well, the 10 milligram vial would not be enough because I need 42 milligrams. So we're going to need to use the 50 milligram vial. It says, what is the volume of reconstituted medication to be administered? Well, it says the medication is reconstituted to a concentration of 1 milligram per mil. So if I need to administer 42 milligrams per dose, I can set that equal to the strength that I have. So 1 milligram per 1 mil equal to 42. Well, we can see that that's a 1-to-1, so this has to be 42 here. If you want to work it out, that's fine, but X would be 42 milliliters here. Now, show the amount of medication to be administered on the following syringe. So once again, in your assignment, if it has you draw on syringes, you don't have to do this, but just to take a look at this syringe, we have a 60 ml syringe, and we need to draw up 42 mils. So 45 would be right here in the middle. So 41, 42 would be at that second mark there after 40. So that would be where our solution would be drawn up to. Okay, let's take a look at this example. I'm on number 15 on page 277. So a patient with a BSA of 1.75 meters squared is being treated for Hodgkin's disease with doxorubicin 65 milligram per meter squared every 21 days. The medication is available in 5, 10, 25, 75, and 100 ml vials in a 200 milligram per ml strength. How many milligrams of medication should this patient receive per dose? Well, I see that my dose is given in milligrams per meter squared, and I have my BSA in meter squared. So I'm going to use that BSA meter square rule. So it says to take the BSA 1.75 meter squared times the dose in milligrams per meter squared, 65 milligram per meter squared. Those will cancel out and I'll be left with milligrams. So 65 times 1.75 gives me 113.75. So that rounds to the nearest milligram of 114 milligrams. Now it says what volume would be used to provide the dose. Well, remember the strength is 2 milligrams per mil. So I always want to set my strength equal to my dose. So 2 milligrams per 1 mil is equal to 114 milligrams over X. So 114 divided by 2 gives me 57 milliliters. Now, which vial would be the best choice? Well, let's see, I got a 5, 10, 25, 75, and 100. These three would be too small. 75 would work, 100 would be a little bit too big, so I would just choose the 75 ml vial, because that's closest to the dose that I need. Okay, so another rule that we have for BSA. So if we do not have an amount per meter squared, so if they don't give us the dose in milligrams per meter squared, but we have either the child's height and weight, or we already have their BSA, and we have the adult dose, we can use this rule to figure out their dose in milligrams. Now you can see this is pretty similar to Clark's rule, but it is going to be more accurate because we're using their BSA. So in this case, we would take their BSA divided by 1.7. So 1.7 is just the average adult BSA. Then we would take that times the adult dose to find their dose in milligrams. So let's take a look at an example of one of these problems here. So here I am on number 13. I'm on the pre-test, page 246. So it says a 10-year-old child weighs 56 pounds and is 40 inches tall. He's been diagnosed with epilepsy. The physician orders Dilantin suspension for this child based on BSA. The normal adult dose is Dilantin 300 milligrams per day in 3 divided doses, so 100 milligrams per dose. So that will be important here in a little bit. So I'm given this information here. You might see 10-year-old and automatically want to go to use Young's rule. But remember, only use these rules if all we have is their age, okay? So age is not going to be as accurate as weight. And in this case, we wouldn't use Clark's rule because we also have their height. So remember, when we have height and weight, we can find their BSA. So this is a child, they're 56 pounds, they're 40 inches tall. So the first question asks us, what is the child's BSA? So grab your nomogram. We need to make sure that we are on the child side. They are 56 pounds. So we're going to make a mark here. So we have 50, 55. There's no other marks in between here. So we're going to have to kind of eyeball. 56 would be right above 55. And they're 40 inches tall. So on this side, make a mark at 40 inches. Now we use our straight edge to line those up. So remember, 56 pounds, 46 inches tall. Sorry, 40 inches tall. 56 pounds, 40 inches tall. So 56 on this side, 40 inches here on this side. Make my mark here on my nomogram. So then we take a look here. I am between 0.8 and 0.9. So here I have 0.2, 4, 6, 8, 10. So I'm going to say 0.2, 4, I'm going to say roughly 6. 0.86 meters squared would be their BSA. So 0.86 meters squared. Now it says, what is the dose in milligrams to be given with each administration? Well, we have their BSA and we have the normal adult dose. So that's 300 milligrams per day in 3 divided doses of 100 milligram per dose. So remember, we're looking for the dose. So we're going to want to use 100 milligrams per dose, okay? So we have the average adult dose, and we have the BSA. So we're going to use this third rule here. So we're going to take their BSA 0.86 divided by 1.7 meters squared. We're going to do that first, and then we're going to take that times the adult dose of 100 milligrams per dose. So let's see, 0.86 divided by 1.7. Just leave that number in your calculator. I got 0.5058, and then it keeps going on. Take that times 100. That gives me 50.6 roughly milligrams. So I'm going to round that to the nearest milligram of 51 milligrams. Now it says, what is the volume of medication to be given for this dose? Well, we got to look at our drug here. The strength that I have is 125 milligrams per 5 mils. So I know that there's 125 milligrams in every 5 mils. So I want to set that equal to my 51 milligrams. So 125x, then I take 51 times 5, which gives me 255, divide by 125. X gives me 2.04 mils. Now, if I'm rounding to the nearest tenth, because my 3 mil syringe would not measure to the nearest hundredth, that would round to roughly 2 milliliters. Okay, so now it says, what is the approximate dose in milligrams using only the child's body weight and average adult dose? So if all we knew was their weight, which we said that was, 56 pounds, and the average adult dose, we said that that was 100 milligram. Well, take a look at your list of rules. If you only know their weight and the adult dose, we would want to use Clark's rule. So child's weight in pounds, 56, divided by 150. And then we take that times the adult dose. So 56 divided by 150 times 100, that would give us 37.3, so roughly 37 milligrams. So we can see the difference of, only using their weight and using both their height and weight here, or their BSA. So then it says, what's the approximate dose in milligrams using only the child's age and the average adult dose? Well, they are 10 years old, and the average adult dose, once again, was 100 milligram. So if all we had was their age in years, we would use Young's rule. So take their age in years divided by their age plus 12. So if we took 10 divided by 10 plus 12, well, 10 plus 12 is 22. And then we took that times 100 milligrams. 10 divided by 22, 10 divided by 22, times 100 gives us 45.4, so rounding to the nearest milligram, 45 milligrams. So just based on their age, that would be 45. Then it says, considering that the BSA calculation is most accurate, are the last two very accurate methods of approximating doses? Well, if they really need 51, we were coming up with 37 and 45. No, they're not the most accurate. So that tells us, the more information that we have about a patient, the better. And like I said, we usually go with the manufacturer's dose. If not, we would typically go with the BSA rule. That would be the most accurate. And then from there, if all we had was their weight, we would use that. The very last thing we would always want to base something on would just be their age, because that could really give us a dose that wouldn't be accurate for that individual patient.